Okay, here we have another problem on a relation. A relation is defined on Z, the set of integers, by A relates B if and only if a+2b is a multiple of 3. Show that R is an equivalence relation. As usual, we have to show that R is reflexive, that R is symmetric, and that R is transitive. Now, we should note that for anything to be a multiple of 3, it must be of the form 3 times m, or 3 times p, or 3 times k. So the relation is defined to us as A relates B if and only if a+2b is a multiple of 3. That means it's 3m for some m being an integer. Now, we want to show that R is reflexive. For reflexive property, A relates A, where A is an element of Z. But for A to relate A will mean that a+2a is a multiple of 3. And this gives us 3a, which is a multiple of 3, which is a multiple of 3. Therefore, R is reflexive. We prove symmetric property. You must not write symmetric property as I'm writing, but for sake of understanding and writing it yourself, you know we're proving symmetric property. For a relation to be symmetric, A relates B means that B relates A. So let us have it that A relates B. Let A relate B. A relating B means a+2b is a multiple of 3. Now, b plus 2a is equal to b plus 2 times 3m minus 2b. This will give b plus 6m minus 4b. And this will give us 6m minus 3b, which is 3 times 2m minus b. And we can write this one as 3k, where k is 2m minus b. And since m and b are integers, it means that k must also be an integer. Therefore, 3k is an integer, and this 3k is a multiple of 3. This is coming from b plus 2a. This means b relates A. Thus, R is symmetric. We go for transitive property, transitivity. Let ABC, or let ABC come from the set in which R is defined. Remember, all these A, B, M, K that we were using are coming from the set of integers. Transitive property says if A relates B and B relates C, then A relates C. So let us have it that A relates B and B relates C. So we want to use this one now and show that A relates C. But A relating with B means a+2b is a multiple of 3, and the B relating C means b plus 2c is a multiple of 3. I can put k where k is coming from z. If we add the two equations, we're going to have a plus 2b plus b plus 2c is equal to 3m plus 3k. Now we're having a plus 3b plus 2c is equal to 3m plus 3k. This gives us a plus 2c is equal to 3m plus 3k minus 3b. Now a plus 2c is equal to 3 times m plus k minus b. This 3 times m plus k minus b is a multiple of 3. We can call this one, we can call this b. I have a plus 2c is equal to 3p. You see that a plus 2c means a relates c. Thus, R is transitive. And since R is reflexive, since R is reflexive, symmetric, and transitive, R is an equivalence relation. Thank you for watching. Do not hesitate to subscribe so that you gain access to any new video that we post, and also remember to share so that together we can learn. See you in the next video.